Hi again. This time, in this video, we will try to dive into a substation to see how it works inside. So we have this, you remember this DAS map here, where we can see that there's some cables going between the different substation and cable boxes.
Mm-hmm.
By the way, everything we see here is also what we call distribution nodes. So all these symbols are actually distribution nodes, but just remember that. But now we're going to dive into one of these distribution nodes. We're going to dive into this one that's called Substation 1. And what you have to notice here, that this substation has a 10 kV or medium voltage line going to a primary substation called ABC.
Yeah.
And then it has a 10 kV line or medium voltage line going to another substation called station 2, right? And it has two low voltage cables or lines going out to cable box called C2 and one called C3. Okay, just remember that.
Mm-hmm.
Okay. Then you go to look at this picture here. Can you see that?
Yes.
Here I try to kind of open up this substation over here, substation 1, and try to draw it how it looks in real life.
This is a red one.
Yeah, this is a red triangle, the kiosk. This is, actually I tried to draw the kiosk, right?
Mm-hmm.
Like this one.
Mm-hmm.
So I think you can
Okay.
see this is like a box, right?
The dog house. We call the dog house in Denmark.
Yeah, the one you call dog house.
Yes,
Yeah, it looks
yes.
like a big dog house or something.
Yes.
Like a tree house.
Yes.
So if you look at it normally, you cannot see what's inside it. But the technician, he can open up some doors. This is some doors. Hope you can see that. And then you can access the equipment inside it.
Mm-hmm.
And in a typical substation, you will find kind of three categories of equipment.
3 panels.
No, not 3 panels. You will find typical what we call the medium voltage. We don't call it the panel, and then we call it the medium voltage switchgear unit.
Mm-hmm.
But
So actually the ABC is the energy provider, for example, Siemens or that kind.
that's the name of the substation over here. I just call them ABC because all the primary substations in Denmark, they are called by 3 letters.
Okay.
And they will typically be called like 3 letters that represent the area then. Because, for example, if there was a substation in Ingum, like we live, it will call ENG or something.
Okay.
So it's nothing to do with the manufacturer. It can be whatever manufacturer.
Okay.
It just means that from this goes the cable inside this kiosk.
Uh-huh.
And just to show that this cable here, it goes to ABC.
Mm-hmm.
So inside it we will have a piece of equipment in one compartment. We call it a medium voltage switchgear unit because it can handle the medium voltage.
Mm-hmm.
And you can see down here there's a picture of a real one.
Mm-hmm.
It looks something like this. This is one from Siemens, but you can get it from ABB, and there's a lot of
How much of the medium voltage? How many volts?
Yeah, that's different from area to area. Sometimes it's 10 kV, that's the most normal. Sometimes it's 15 kV, 15,000 volts. Sometimes it's maybe 12,000 volts. It's just medium volts.
Okay.
So you buy this stuff so it can handle. You see, it can handle up to 24 kilowatt actually. This one.
Mm-hmm. Mm-hmm.
Okay. So, but it's just medium volts.
Mm-hmm.
And because there comes a medium voltage line into it, and it has to go a medium voltage line
To the next one.
The thing will have 3 bays at least. And you can say, why not 2, why 3? This is because the power will come in here, then it will be connected to one bay here,
Mm-hmm.
and this bay will kind of lead the power up to a bus bar. There's a bus bar inside this
Yes.
box. And it will go through here and down here to the next station.
Mm-hmm. And you have also the switch
Yes, there's some switches there you can open and close.
Mm-hmm.
For example, if something happens in the network, they can open and close these switches.
Mm-hmm.
Or if they have to de-energize energize something, or maybe they have to. There's a lot of reason they might do that. So also if something happens, you see here the fuse, so it can automatically shut off. So it's to protect the equipment. And the two things here, I don't know if you can see, is two weird stuff going out here. That's what we call a fault indicator. And it's a symbol here, I showed as a symbol.
Mm-hmm.
And what that thing does is if this cable gets short circuit, that means someone dig into it or something. So
Mm-hmm.
it kind of,
Or maybe someone just drive into it and break.
Yeah, if you drive into a substation, but the cable's in the ground, so they cannot drive into that.
Okay.
Low voltage, they can drive into the cabinet. But yeah, if something happened to that cable, typically someone dig into it,
Mm-hmm.
then it will short circuit.
Okay.
And then they can see on these indicators which cable was actually, if there's a short circuit indicator in here, they can see where was the fault. So it's very important in fault finding. That's why we have to register what kind of short circuit indicators are put into the substation.
So they can see exactly which one is broken before they have to go to the real place and fix it.
Yeah, if they have a power outage in this
And
area.
then they can save the time.
Yeah. Because if someone complains here, they're out of power, right? They have to figure out what happened.
Mm-hmm.
They will go into the substation and look at these short fault indicators to look. Okay, this fault indicator says this line has been short circuit.
Mm-hmm.
Okay, then they know someone dig this one
Okay.
over this one,
Okay.
for example. So, and yeah, but it has 3 bays. The last bay here is, by the way, what we call this bay, we call this a line bay because it's connected to a line.
Mm-hmm.
This one is also a line bay. Someone call it a cable bay because it's connected to cable, but more general name for it is a line bay. And this one here we call a transformer bay
Mm-hmm.
because it's connected to the transformer. Because as you can imagine, the power goes into this thing here,
Yeah.
goes to the next station. However, this station here has to transform the power to the customer
To
in
the
this area.
house. Yeah.
Yeah.
To around 400 volt.
Yeah.
Yeah.
So what is it that goes a cable from this bay here into another compartment inside the substation where the transformer is.
Mm-hmm.
And you can see down here how the transformer looks like.
Mm-hmm. I zoom in a little.
This is a kiosk that has one transformer.
Mm-hmm.
And you can see here actually it can have several transformers.
Mm-hmm.
So it's just to show that there can be more equipment than shown here.
Mm-hmm.
But more about that later. The typical case is that it has one medium voltage switchgear unit
Mm-hmm.
and one transformer and one low voltage panel. And each of these here we also call a bus or bus bar circuit. So actually this guy and this guy works the same
Mm-hmm.
theoretically. It's a circuit, it's a bus bar with some stuff on, right?
Mm-hmm.
Some components on. So from a electric perspective, it's the same thing. And in the data model, I just call this thing a bus bar circuit. Okay, but I'll get back to that. Okay, so the power runs into the transformer here, the medium voltage power,
Mm-hmm.
and it goes into something called the horn. We say that the power transformer has 2 horns, a medium voltage horn.
Like
and
buffalo.
yeah, and a low voltage one.
Mm-hmm.
They do, so look like that, something like that.
Mm-hmm.
And it will convert the voltage from, for example, 10,000 volt to 400 volt.
Mm-hmm.
And then it goes the cable out of it
Mm-hmm.
and goes into the low voltage panel.
Mm-hmm.
And here you can see an example of a low voltage panel.
Mm-hmm. I zoom in a little. Yes.
And actually you can see here in the middle there's some kind of big switch thing. And this is the one that is connected to the power transformer. So you cannot see the cable here, but that's probably going a cable out of this, or maybe there's some copper or something going out of this and it's connected to the power transformer. So this is this one I draw here.
Mm-hmm.
And this can be some kind of breaker, like what we call the maximum breaker, that will automatically shut off if someone used too much power, so this one don't get damaged.
Mm-hmm.
Or it can be a simple switch or a fuse or something like that. It depends on how they build it.
Mm-hmm.
So there will always be like one bay. We also call these things bays here, right?
Mm-hmm.
So there's 4 bays here.
Mm-hmm.
The first bay contains some switch
Mm-hmm.
that protect the transformer or protect the panel here. And then the power will go into that switch, and it will go to this. This is a fuse switch disconnector.
Uh-huh.
It's also a kind of switch. It is a switch. And it power will go down to that and to the C2 cable box. We have it here. Right?
Yeah.
So imagine that something happens out here. Someone dig over this cable, or as you talk about, someone drive into this cabinet,
Mm-hmm.
for example, and something like will be a short circuit.
Mm-hmm.
Then this fuse here will blow, poof,
Mm.
and then there will run no power anymore.
Mm.
So again, it's to protect the circuit.
Mm.
Right. And I draw here that there's like 3 fuse switch disconnectors, and there's one here that's not connected, so it's spare, right? So it has 2 that is connected to C2 or C3, and then there's an extra one.
Mm.
Just to show that there can be, normally there will be many more. Like you can see here, the example here, there's 8, right?
Yes.
8 and 1 switch. But just to show that can be someone that's spare, and it's important for the technician to register when he uses the app and he see, oh, okay, it has this, this, and this. Okay, it also has some spare ones. We have to register them too,
Mm-hmm.
because the next time if they have to connect, maybe they have to build a new area here. They have to connect a new
Yes,
cable box.
because sometimes someone just build some new houses and then they need more power.
Yeah.
So we have the spare one.
Yeah, then they
Yeah.
don't need to come and put a new one in.
Yeah, and then they can connect later.
So that's why it's important for that they can register also the one that's not connected yet, because then they have in the system they can see, okay, there's some spare one here.
Mm-hmm.
Because today many systems don't have this stuff registered yet.
Yes.
Okay. So yes. So if you look at the substation from helicopter perspective, well, it's just a box, right? It's a substation enclosure, a substation container or whatever you call it. And when you dive in one more level, you can see there's some medium voltage equipment, some power transformers, and some low voltage equipment.
Mm-hmm.
Or we can say it has a medium voltage bus bar circuit, power transformers, and low voltage bus bar circuit.
Mm-hmm.
So it can have several of these, and it can have several of these, and it can have several of these.
Mm.
Right. But normally it has like this.
Mm-hmm.
This is 95% have something like this.
Uh-huh.
Okay. So I think that's how the substation works inside. Does it make sense?
Yes.
Okay, that's good.
Should we go to the next one?